All right, you ready? Hope you all had a good weekend. Next week there's a holiday on Monday. You all know that? That doesn't affect us, but if you have a Monday class, don't come to school. All right, so I've been asked to address this homework question on order of operations number 15. And yeah, that looks pretty bad. So I'm going to do our PEMDAS thing. Remembering that multiplication, division, addition, subtraction, we do from left to right. So first thing that I see is that set of parentheses. So I need to figure out what this is, if it's possible. And it is possible for me to put those two fractions together. And if I'm going to subtract two fractions, I must have a common denominator, right? So what would the least common multiple of those two numbers be? 12, right? So I need to turn both of those into 12s. So I could multiply the top here by 3 and 3, and then over here 4 and 4, right? Just multiply straight across. We should get 3 over 12 minus 8 over 12. And now we can combine them together. 3 minus 8, negative 5. So negative 5 over 12 is what goes in there. So this equals negative 5 over 12, but then I'm going to square that over 2 cubed plus a half divided by 3/8. So what should I do next? You want to go ahead and square that? Because we have an exponent, right? We do have parentheses still, and it's important that I put the parentheses, right? Because you're going to square a negative number. Remember I showed you that if the parentheses aren't there, then it turns out to be negative. So I want to square this. I can also cube the 2 while I'm at it. All right, because these are separated by the division, we can just do them separately. So let me do that. What is negative 5/12 times negative 5/12? 25 over 144. All of that over 2 cubed, which is 8. Like that, right? And notice how I made this division bar larger, right? That's to separate the fraction on top from the number 8 on the bottom. And because I realize this is kind of complicated looking, I'm going to write this 8 as 8 over 1. And that way it looks more like a fraction over a fraction. Is that okay with you?
Yes, sir.
Okay. Divided by 3/8. So I didn't do anything else yet. Now at this point, I'm going to do parentheses, exponents. I don't see any more. Multiplication and division from left to right. So I see this as being a division. Do you see that? Fraction divided by a fraction. So I'm going to go ahead and do that over here, like on the side scratch work. 25 over 144. I said 25. I wrote 24. Thank you. 25 divided by 144 divided by 8 over 1 is the same as multiplying by the reciprocal, right? So I multiply it by 1 over 8. Ew, this is ugly. So this is 25 over, and maybe it's time for us to break our calculator out. 1152. Okay. 1152. Thank you. So that's what we get right there. Oof. So this is 25 over 1152 plus 1/2 divided by 3/8. Now what? Do this division first, right? Before the addition. So I'm going to divide that. But division is the same as multiplication of the reciprocal. So again, I'm going to change this into multiplication. And I'm going to flip this over and make this 8 over 3. And then multiply those two straight across. So 25 over 1,152 plus, what, 8/6? Do you want to leave it as 8/6? I could reduce it, right? I could reduce that to 4/3. Let me go ahead and do that on the next line. This is 25 over 1152 plus 4/3. Common denominator. Does it go in there? It does go in here. So 1152. So what do I have to multiply 3 by to turn it into 1152? 304? 384. Top and bottom. Like that. That's ugly. So we have 25 over 1152 plus 4 times this, which is 1536, and then over 1152, and then add together on the top. 1561 over 1152. And I don't know, did anyone try and reduce that? No, it doesn't go. Did anybody check their answers with the solutions? You know what I'm talking about, right? You saw them? So I put the solutions up yesterday, I think, maybe earlier. If you go to class files in Canvas, click on files, go in there, there's now a document in there that has the solutions to the entire packet.
Can't do it.
What's that?
Can't check it right now?
No, just check it later. Yeah. You checked it, right? And that's it? Now look, there are this document that we're working with in the solution manual that I provide you. There could be errors in it. I'm just letting you know that right away because I'm not part of the group that's put the packet together and that's putting the solutions together. And every semester they have edits and corrections and things like that. So if you see something in there that just doesn't look right, just let me know, okay? I give you bonus points if you find a mistake. All right? Sound like fun? You like bonus, right? Okay, does this answer the question? Does this address the issue? Okay. Anything else? When is our first exam? I feel like it's coming up. Is it too early? We have 4 exams in here, so we've got to have one coming up soon. Oh, wow, no. Wow, really? Wow. We don't have one till late September. All right. So we're still like 4 weeks away or so.
On exams, do you get to use a calculator?
You can use your calculator, yes. Mm-hmm. Which is why it's important for you to get it and get familiar with it. So by the time you come to the exam, I've had students come in, they're like unpacking their calculator from the wrapping the day of the exam, and you know, that'll probably help you to have it, but still, like, you want to be familiar with the keystrokes and where things are, and you don't want to be trying to learn that while you're taking a test. All right, so no other questions on the homework? Okay, now we did not finish the topics that we were covering last time. We stopped and we needed to solve linear equations in one unknown. I also emailed everybody that take-home quiz. I emailed it to you yesterday. I had told you I was going to email it on Friday. I had issues. I sent an email out to the class saying, hey, I'm having issues. So I sent it out yesterday. It will be due a week from today. All right, so you have all weekend with it. And by the time we finish today's material and Thursday's material, you should be able to do everything on that take-home. It's a review, okay? Everything on that take-home quiz is a review of things that hopefully you've seen before you got here, including what we're doing today. So we're still reviewing, all right? And right now we're doing solving linear equations in one unknown. So I thought that we would just start with the first problem. These get progressively harder, and then they start having fractions in them. And so I'll just kind of pick, or maybe I'll let you pick. I'll start with the first one, just to make sure we're all on the same page here. I have 5x minus 2 times x minus 2 in parentheses equals 4x, and then minus 10. And the instructions here are to solve the equation. That means we need to figure out what value of x we could put in here that would maintain the left and the right hand side of this being equal. And we have a very systematic way of doing this. There's this, like a procedure almost on how we do this. But the first thing we have to do is recognize what it is we're looking at, and this is what we call a linear equation. And there's a couple of things that tell you that. First of all, there's an equal sign, so it's an equation. It's linear because the variable x has kind of this imaginary 1 up here that you can't see, that you don't normally write. It's x to the first power, as opposed to like having an equation that would have that in it. This would not be a linear equation. This would be what we call a quadratic equation. So we need to make sure that we're aware of what we're looking at before we start. So this is a linear equation, and there's only one unknown variable. That's why in the title it says in one unknown. There are such things as linear equations with two variables, and we will talk about those later. But if you have a linear equation in one variable, then we should be able to get an answer. Hopefully, we'll see. So does anyone know what the procedure is that we do to solve a linear equation? Like, what's the main goal here? Get x by itself on one side of the equation. And you're always allowed to add anything to both sides, subtract anything from both sides, multiply both sides by something, and divide by something, right? You can do that with one exception. You can never multiply by 0, and you can never divide by 0. Those are the two things you can't do. So if I'm going to try and get the x by itself, I realize that x is on the left and the right. So I'm going to have to choose at some point which side I want my x's to be on. And that's up to me, up to you, right? You can decide. But before you can start doing that, you have to release the x from this parentheses. Right now it's trapped inside here. You have to free it. The only way to do that is to distribute that 5 through, which is really multiplying the 5 through the parentheses. So what is 5 times x? 5x, right? And then what is 5 times negative 2? Negative 10. Equals, and then on the right side, there's nothing I need to do, right? 4x minus 10 is 4x minus 10. We've freed the x from the parentheses. Now, before we go any further, we just want to make sure on the left side, can we combine anything together? Like terms. Is there anything that we can combine? No, right? Can't put x's together with numbers. Same thing over here, can't do anything. So if we can't do that, then we move to the next step in the procedure, which would be to get your x by itself. So this is where you choose the side, and it's up to you. So what do you want? Left side, right side?
Subtract 4.
You want to subtract 4x on both sides, which would make it go away here, and it would still be on the left side. So I'm going to subtract 4x, and I'm going to do this vertically. We're going to do it vertically like this. There is a way to do it horizontally, but I'm going to do the vertical subtraction, because that's what most people have seen. When I subtract 4x from 5x, I'm left with what? A single x, which I can just write as x. I still have the minus 10 here. I still, of course, have to carry the equal sign down. This is gone, and I'm left with negative 10 here. And finally, I'm trying to get this x alone, I need to get rid of the minus 10. So add 10. And this is gone. We just have the x, and then over here, 0. X is 0. That's supposed to be the answer. That means if I plug this in for x, right, I should have a true equation. I'm going to check it, although I'm not going to require you to check it. If I rewrite the original problem and I replace all the x's that I see with zeros, I should get a statement that makes sense. So 0 take away 2 is negative 2. And then this is, of course, negative 10 when you multiply. Is that equal to, this is a question, is that equal to this side? Well, that's gone, and that's just negative 10, right? So it's good, works, right? So, I mean, you can check your answers, right? I mean, if you're taking a test and you're doing this, right, you can always check to see if you got it right. I mean, you would know, if you checked it, you would know right away if you did it correctly or not. All right, that one was pretty straightforward. I think number 2 is very similar to that one. What's the difference on number 2? Do you see anything that maybe you would have to address? On the left side, you have 2x minus 5x. You would have to combine those together first. What would 2x minus 5x be? Negative 3x. So that's a little difference on that problem. Other than that, you're going to distribute the 3 through. You'll be in good shape. Let's do number 4. 4. I think 4 is more interesting than 3. All right, so I've got 3 minus, then parentheses, 2 minus 7x, and then I have equals 2x minus parentheses x minus 1. All right, is this a linear equation in one unknown?
Yes.
Yes, equal sign, x is there, x is to the first power and all those, so we are going to use the technique of trying to isolate x by itself. So I look at the left side, look at the right side, and then I decide, okay, I need to do some work. I've got to get this x out of this parentheses, which means I must distribute, right, to get the parentheses to drop. What am I going to distribute through that parentheses? -1, right? Not a 3. This 3 is separated, right? This is 3 minus this. We look at this as being like a -1, and then we can multiply that -1 through the parentheses. And the 3 is just going to come down. It's just going to follow us. So we've got 3 and -1 times 2. -2 or -2, you can say it either way. And then -1 times -7x plus 7x. So negative times negative is positive, right? We good? And then over here, 2x comes down, and then again, we have to free this x from the parentheses, so I'm going to distribute this -1 through this parentheses to give us a -x, and -1 times -1 would be +1. So are there any questions on that step? You all right? All right, now we look on the left side. Can we do anything? Can we put anything together over here? Yeah, 3 minus 2, right? These are like terms. 3 minus 2 is 1. So that just gives me 1 plus 7x. Then equals, on this side, can we put anything together? 2x, take away an x, leaves you with just a single x, right? So this is like 2x, take away 1x, that leaves you with 1x. I'm just going to put x plus 1. Now there's nothing else we can do on the left, nothing else we can do on the right, so now we have the choice of getting all of our x's to the left side or to the right side. I think the left side is going to work again here. If I just take x away here and take x away here, it'll go away on this side. So subtract x, subtract x. Now, depending on your comfort level with this, some students are to the point where you can also take care of the numbers right now. So should I try and take care of the numbers right now or just wait and do it on the next step? What do y'all want? Do it now? Okay, if this x is going to go away on this side, I'm going to have 6 x's over here, right? I don't want this number over here. So I'm actually going to take the 1 away on both sides at the same time. So that way I'm kind of like killing 2 birds with 1 stone. I'm moving the x's to the left and then getting the numbers to the right. We're going to get the same answer. Okay, this is 6x equals 1 minus 1 is 0. Now we're not done because we need x by itself, and right now it's not. So how do you undo this? Divide, right? Because that's multiplication. So to undo the multiplication, you divide. And when you divide here by 6 and divide here by 6, the left side becomes just a 1 in front of x, which is just x. But the right side, 0 divided by 6 is 0. That's the same answer that we got earlier, isn't it? Now we could check it. It works. Okay, so it is right. Okay? Questions? All right, you do number 3. Go ahead. It's so quiet in here. I'll play some background music while y'all are. Is that okay? Come on, y'all are so quiet. It can't be that bad. I know, I'm giving you a hard time. If you get it, raise your hand. I want to just come by and see what people are getting, how long it's taking them. Okay. So far, everyone that I've looked at has the same answer.
Is it the red?
I don't know. Just reduce it. If we all get the same answer, that means it's right? I think it should be negative. Everyone else is getting negative, so just double check some of your signs on that. And if you get it and your neighbor's having trouble, I mean, you can help them. That's I don't want to force you to be friendly. That's what everyone else is getting. Yep, that right there. It's looking like -3/2 is the answer most people are getting. Now, if you're hung up on it, you need to ask for help. That's what I'm here for. I don't mind coming by and kind of nudging you in the right direction. Are you good, sir?
Yeah.
Yes? You all right? Okay.
Try eliminate.
6, 10. That's right. Okay, so you need to move this. You need your x's on one side, which you're not there yet. So which side do you want your x's on? On this side? Okay, that means you have to take 13 x's away on both sides. There you go. And then 9, take away 13, x, and then you're there. You just need to divide through by that answer. That's the right thing. All right, the work is on the board. The only thing I really want to point out is just to be careful here with this parentheses, that it might confuse you, like what am I supposed to do with that? But if you ever see like just plus a parentheses, you can just drop it, because there's really like a 1 out here, and the 1 distributes through and doesn't change anything. And then everything after that, I don't know, hopefully you got. Anyone have a question on this?
What if you subtracted the 9 instead of 15?
So what if you would have done it and like taken 9x away from both sides? Well, it would have looked like this. The good news, okay, is that we should get the same answer, all right? That's the good news. It would really suck if you did it one way, I did it in a different way, and we got different answers, right? 4x plus 10, that's where you should have been. Then you would have subtracted 10 on both sides. And this would have given you 4 take away 10 would have been -6 equals 4x. And then you would have divided by 4, and then you would have been exactly the same place. All right, let's move on. Let's try, I think 5 looks worse than 6. Let's try 5. So we have 3, and then in parentheses, t minus 7 over 2 equals t take away 6. All right, this is still a linear equation in one variable, because we have an equation, and the variable we have is to the first power. And also the t we have does not appear in the denominator, which would cause it to not be a linear equation. So it's a good thing that it's up here, and that really you can look at this as a fraction. It's on the top. So any ideas? Distribute the 3 first, right? Because that'll at least get the parentheses out of there. So 3t minus 21 over 2 equals t minus 6. That's completely a legitimate move. I'm okay with that. Now what? And multiply by 2. Okay, so let me just remind you of something here. The way that math works is we're trying to get from point A to point B, right? Point A is here, point B is the answer. And there is usually a shortest path between these two. And that's someone who's very experienced with algebra, knows, like, has seen thousands of these, and they just know the most direct way to get there. But it's not to say that there aren't other paths that will lead you to that point also. So you may multiply by 2, someone else may do something else. As long as you do not break any rules of algebra, you will be on a path. Now, as long as you don't break the rules, your path may wind up being very long and hard, but you might eventually get there. As soon as you break a rule, though, you're pretty much not going to be on a path, all right? Unless you accidentally break again and get yourself back on a path, but by making 2 mistakes. So just keep that in mind. When I'm demonstrating these things up here, you may have a way that would have worked. I'm just showing you, like, what the response from the class is. If it's legitimate, I'll go with that, all right? So I'm being instructed here to try 2, multiplying both sides by 2. Why?
Because it's being divided by 2 on the left side.
Okay, so you see the division by 2 on the left side, and you really are just thinking maybe you don't want to work with fractions, like you don't like this fraction. So if I multiply the left side by 2, the fraction will go away. What do y'all think about that? That sound okay to you? All right, so when I multiply both sides by 2, I'm really multiplying by 2 over 1, right? Just to be clear. And then on this side, I'm not going to write 2 over 1. I'm just going to write 2 in parentheses. You okay? Do you? All right, you can step out if you're not feeling. You look like you're not feeling well.
Is it okay if I just like
Yeah, that's fine. Go. I remember one morning my dad was taking me to school, and I guess I looked really bad. I was like in, I think, 5th grade. I was sitting there in the truck waiting for him, and I felt fine, but I guess I looked terrible that morning. And he's like, "Son, are you okay?" And I'm like, "No." And he's like, "You know what? Why don't you just go inside, stay home today?" I'm like, "Okay, thanks, Dad." Went inside and like played video games all day. It was awesome. So,
count it like all day?
no, you're good. You're good. No, you're good.
Thank you.
You're good. Yeah. So all you have to do is look bad, and I'll let you go. No. You look like you're going to be sick. Here, I'll cover you. Go. 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 Okay. All right, 2. So the only reason I'm doing the 2 over 1 again is because I want everyone to be clear that this 2 and this 2 are going to go away, which is the whole reason we do it. All right? You do not need to pass the 2 through here, although you could. Oh, my paths are gone. That would be okay, all right? It's just that you're not going to get the 2 on the bottom to cancel. It's still going to be there because you put the 2 up here. So I'm going to do this. And then on the right side, I must distribute this 2 through. And it's important that when you multiply this side by 2, because you had 2 terms here, terms are separated by addition and subtraction, the 2 must go to both, must pass through to both. Any questions on that step? Sure? You don't look good. Are you okay? No. Everyone at this table looks bad now. All right, so what's on the left side? 3t minus 21 equals 2t minus 12. And now we're back to kind of what we've been working with now. This is, we've done like 2 or 3 of these now where we get them to this point. It's just a matter of moving the t's around. So what do you say we put the t's on the left side? If we put them on the left, that means we need to take them away from the right. So I'll subtract 2t. That should take care of the t's over here. And if I'm going to move the t's to the left side, that means I need to get this to the other side, which means I should add it to both sides, right? Add 21. Are y'all okay with me doing this all in one step? Yes? Okay. These 21s cancel, these 2t's cancel. I'll be left with a single t on the left, because 3t minus 2t is just t. And then negative 12 plus 21. 9. This one looks easy enough to check. Because if I plug 9 in right here, it looks pretty easy. 9 minus 7. 2. 2 times 3? 6. 6 over 2. 3. So the left side's 3. 9 minus 6? 3. So it's true. Right? Works. All right. Yeah, the next one's just really straightforward. 10? That's the one I was looking at right there. I think 10 looks like a good one. 7 looks almost identical. Let me do 8 before 10, because 8 is actually a little problematic. And there are a couple of different paths you might want to take to get you to the answer. So I'm just curious to see how we're going to go about this one. We do have a linear equation with one unknown, and I've got a lot of x's, don't I? I don't see any parentheses, so there's not going to be any distribution. On the left side, can we put those two together? These two? I mean, are they like terms, is what I'm saying. They are like terms, right? But to put them together, they'd have to have the same denominator. So would y'all like to do that? Okay, does anybody have any other recommendation or suggestion as to the path they would want to take?
You could add 1 and 2.
You could do what?
Take away 1 from the right side and add it to the left side if you wanted to.
Yeah, you could, you mean put the 1 on that side? Yeah, you could do that. That wouldn't be wrong. You'd be on a path. So I'm okay putting those two fractions together. I'm just curious, was anyone taught that if you ever have an equation that involves fractions, that you can just find the LCD, the least common denominator, and just multiply both sides by the LCD, and that would clear your fractions? No? This doesn't sound familiar? No? What I'm saying is, like, what is a common denominator from both of these? 35, which we would need if we were going to put these together, right? But because it's an equation, you could just multiply both sides by 35. That doesn't ring a bell? No? So would you like me to put these two fractions together, or would you like me to show you the clearing of the fractions with the 35? You want to see it? Okay. So let me just, again, put a little asterisk here. If you have an equation that involves fractions, and you don't like the fractions, which I know you don't, then you find the common denominator and you multiply both sides by that common denominator. So my common denominator is 35. I'm going to come in here. On the left side, I'm going to multiply by 35. On the right side, I'm going to multiply by 35. Now my numbers might get a little bit big here, but I guarantee at the end of this, I'm going to have no fractions. When you multiply the 35 through here, you can do this several ways. 35 times 2/5. You could figure out how many times 5 goes into 35, which would be what? How many times does 5 go into this? 7. And then you still have a 2 up there, right? So it'd be 7 times 2 would be 14. Or you could actually multiply 35 times 2, which is 70, and then divide by 5, and you would get 14. So it's the same thing. No matter what, you're going to get 14x. Are y'all okay with that? Yes? Okay. 14x. What would happen if you multiply it to this? What's 35? I'm going to write it as a fraction. Over 1 times negative 5 over 7x. What's that multiplication? So I like this way. 7 goes into 7 once. 7 goes into 35 5 times. 5 times negative 5. Negative 25 over 1, which is just negative 25x. And then on the right side, these are a little easier to multiply. 35x minus 35. We good? No fractions. And remember, all we did was multiply both sides by 35, which you're allowed to do, right? You can multiply both sides of the equation by anything except 0. So this was a legal move for me to do that. And it miraculously gets rid of my fractions. And I'm more comfortable working with it this way. So let me try and combine these together. What are these two? Negative 11x equals 35x minus 35. I'm going to go ahead and take this 35x and move it over to the other side. So subtract 35x on both sides. What's that? Negative 46x equals negative 35. And finally, we can divide both sides by negative 46. X is, let's see, it's a positive number, isn't it? Because a negative divided by negative is positive. And yeah, does it reduce? I don't think so. I don't think it does. So we're done. Now, are we comfortable with that, or would you like to see me put those two fractions together and do it the way that we were going to start? Or are we okay? We don't want. Don't care?
We're okay.
Everyone's okay? All right. All right, so yeah, let's look at 10. Oh, I'm just moving through here. These. Was 10 the bad one? Yeah, 10. 4 minus 1/3, and then 2 minus 7x equals 2 times x minus 1. This is a linear equation in one variable. I'm going to free the variable first, all right? Parentheses, distribute through. So the 4 is going to come with me. And then I'm going to distribute a negative 1/3 through this. So what is negative 1/3 times 2? Negative 2/3, right? You just write it, 2 as a fraction, go straight across. So we get negative 2/3. What is negative 1/3 times negative 7? Negative 1/3 times negative 7. I'm going to write that as a fraction. Positive 7/3 x equals, on the other side, 2x minus 2. I want you to finish this right now. And if you'd like, you could do what I just did on the previous problem. Because you see the fractions, and you don't like the fractions, so you could clear them. What would you multiply both sides of this equation by? 3. Why don't you try that? Since I showed you how to do it on the previous problem, right now, come in here on your own and do 3 on this side and 3 on that side, and see if you can get to a nice equation with no fractions. And also, don't do this until you've released them from the parentheses, all right? It's dangerous. It can be done, but you have to be really comfortable with your algebra to multiply up here by 3, all right? If you do it up there, I'm concerned. So just first free it and then go with a 3. Yes? Might be hard for me to tell. Let me see. Okay, we'll see what other people get. I mean, we could check it. You could just plug it in, right? should be getting negative 16. All right, are we good? You okay? I think the biggest issue that people have on something like this is the actual 3 times this. And just remember when you do that, you're doing 3, and just write it as a fraction, times negative 2 over 3, and just multiply straight across or just cancel these 3's out, and that would give you your negative 2. Okay, that's where that comes from. And then the same thing from here to here. Just bring the x along with you. After that, it's everything else we've been doing. Okay, there's one last little section here. Look at number 1 and number 2 on those that part C. Do you see a difference between number 1 and number 2? Or did they accidentally write the same thing down twice? What happened? There's no equal sign on the first one, right? Nope. Versus x over 3 plus 1/4 x equals 1. All right, what we have here is just an illustration of making sure you understand the difference between what we call an expression versus an equation. An equation can be solved, okay? We should be able to get an answer, x equals 5, whatever it is here. And that x equals 5 means if we plug 5 in, this is true. The left and the right-hand sides will be equal. An expression is just that. It's just an expression. It's like a statement. Here it is. Here's the statement. There's no answer or anything like that. It's just there. There it is. There's nothing to solve for. Now, with expressions, what we can do is we can simplify them. We can make them look prettier or make them look different. Kind of like if I write 3x plus 2x with no equal sign, that's an expression, right? But what's another way I could write that? 5x. So I could simplify this and say that this is equal to 5x, right? This is equal to 5x. As opposed to this, where I'm actually giving you something to solve, right? If I say 2x equals 4, then hopefully it's obvious that, well, x has to be 2, right? 2 times 2 is 4, so there's an answer. So that's what we're trying to get you to see here, all right? The difference between an expression and an answer. An equation. So for this, if I wanted to try and do anything to this, the best I could do is simplify it. That's it. And to simplify, what I could do is maybe put these two x terms together, just the way you would add 2x and 3x to become 5x. So, what's x over 3? Well, that's the same as 1/3 times x, and this is plus 1/4 times x, and then minus 1. So what we're saying is that this line is equal to this line. So this x over 3 and this 1/4 x, that's two different notations for the same sort of thing. And we're just making sure, by putting it here, we're just making sure you understand that this is this. That's what it represents.
So x over 4 would be 1/4 x.
X over 4 would be 1/4 x. Yep. And now I can put these two together, right, if I get a common denominator. Can I get an LCD and multiply both sides here? No, I don't have both sides. There's no other, this didn't start as an equation, right? So I can't do that. So I'm going to have to turn this into, what, a 12 on the bottom? So I'll multiply 4, 4 like that, and then over here, what, 3 and 3? I'm squeezing it in there because I don't want to rewrite it. So this becomes 4/12 x plus 3/12 x minus 1. And now that these have the same denominators, you just add the numerators up. 4 plus 3 is 7. So 7/12 x minus 1. That is the expression simplified. Now compare that to this. If you wanted to go and try and solve this equation, right, solve it, then you could come in on both sides with something, right? You could multiply this side by 12 and multiply this side by 12 also. And when we do this times this, the 12 divided by 3 becomes a 4x. And then over here, 12 divided by 4 would become a 3, and then you have an x, so plus 3x. On this side, 1 times 12 is 12. Then you could combine these two together. And finally, divide by 12. Divide by 7. And your answer would be 12 over 7. See the difference between these? Your answer here is an expression, just looks a little bit nicer than that. And the answer over here is an actual number, 12 over 7. All right, that should do it for that section. So you should be able to do the homework now. I only had you do part A, but you should be able to now do part B. And go ahead and skip this synthesis thing. I don't even understand it. Okay, so just skip that. And we're going to move on now to operations with polynomials. Y'all hanging in there okay?
Yes, sir.
All right. All right, a polynomial, just so you remember, is anything that looks like that up there. See all those, like 3a plus 2a squared plus 3a cubed? That right there is called a polynomial. This right here is another polynomial. And what I'm doing is I'm subtracting the two. So when we say operations with polynomials, you need to be able to, in this class, add polynomials, subtract polynomials, multiply polynomials. You are not going to be required to divide polynomials, which is a really good thing for you, all right? That you don't have to do, does anyone remember long division with polynomials from high school? It was ugly, so we don't have to do that. All right, so let's look at this. Let's look at the second one. No, third one. The third one looks like the best. 2/7 a plus 2a squared. That's not squared. Plus 3/5 a cubed. That's all in parentheses. Minus another parentheses, a minus 2/7 a squared minus 3a cubed. All right. I have this big polynomial right here, and I have this one over here, and I want to subtract the two. This is not an equation, right? This is not an equation. This is an expression, and so I'm trying to simplify it. Now, I am going to say that that expression is equal to, so I'm introducing an equal sign here, but it didn't start as an equation. I'm going to try and get rid of these parentheses. So on this first expression, can I just drop these parentheses?
Yes.
Yes, because there's really like a 1 out here, and you'd pass the 1 through, and it would just be this. So 2/7 a plus 2a squared plus 3/5 a cubed. And that's it. We're done with that part. Now this one, to drop the parentheses, I must distribute that negative through, and that negative is like a -1, and it just multiplies through like this to all three of these terms, 1, 2, 3. And really it just has the effect of changing the sign of what it was, right? Like if this is positive a, it's now going to become negative a. If this was -2/7 a squared, it's now going to become positive. So it just switches the signs of everything. So I will have minus a plus 2/7 a squared plus 3a cubed. All right. That's where I am. We good? Now what we do is kind of what we did with the linear equations when we combine like terms together, like we got the x's together, or we put the numbers together. Here we have the same concept, but we all have to be clear on what like terms are. So to be like terms, you must have the same variables raised to the same powers. So let me start with this first one. I have a 2/7 a. Do I have any other expressions that have the variable a, just the variable a? Negative a, right here, right? This right here. And that I could look at as -1, right? Those two are the same. And while we're doing this, and I've got all these fancy colors up here, how about the positive 2a squared? Do I have any more a squareds? Ah, right here, this one right there. So those are like terms. I'm going to combine those together. And then finally, I have positive 3/5 a cubed, and over here I have positive 3a cubed. Now, what is it that you have to do to combine like terms together? What do? Add them, right? So if I have like 2x plus 3x, you all would be comfortable saying this is 5x, right? And all you're doing there is you're taking 2 and you're adding 3, right? 2 plus 3 is 5, and you just bring me like x along. Same thing here. I'm going to try and take 2/7 a, and I'm going to subtract 1a. So really I need to do 2/7 minus 1, right? And then I'll just bring a along. So maybe I need to do that on the side, scratch work, because maybe I'm not comfortable doing it in my head. So I'm going to go 2/7, I'm going to subtract 1, right? Which is really 2/7 minus 1/1. So that I have two fractions, and then I get a common denominator, which would be 7, so turn this into 7/7. And now just do the subtraction. 2 take away 7, -5/7. So I know that these two together, right there, become -5/7a. -5/7a. Now I have to do the same thing for the green ones, right? So I'm going to take 2. What am I doing here? Add 2 plus 2/7. That's what I need to do. Which is 2/1 plus 2/7. I need a common denominator. 7, so I multiply top and bottom here by 7. 14/7 plus 2/7, which is 16/7. Positive, right? Plus 16/7 a, that was a squared, right? Yes?
All I did was just add the 2 and the 2/7 to make it a mixed number. Is that okay still? Or?
Yes, and it's definitely shorter, but remember what I told you? I did talk about mixed numbers, right? And that we kind of want to wean ourselves from those. Now, look, this is really the last math class for most of you. So when I say we don't really want to use mixed numbers, it's because if you were going to go on and do more math, if you were, we just don't use mixed numbers. Because, well, you should be as comfortable with these as you are with mixed numbers. And later on, if you were in a calculus course or something, you would 2 plus 2/7 you should be able to do in your head without any trouble, right? I mean, that's the idea. So, all right. Now, let me tell you the reality, because I teach calculus. my calculus students still can't add 2 plus 2/7 in their head, but they can do it. It just takes them a little while. Last thing we have to add together, 3/5 plus 3, right? 3/5 plus 3. (18/5). I'm not going to do that one. I'm just going to put it 18/5 a cubed. Done. We are done. There's nothing else to do. We just subtracted those polynomials. This is the result. Done. So adding and subtracting works pretty much the way you think, right? I mean, you just add these, what we call these numbers in front of coefficients. You just add the coefficients and you're done. Now multiplication is a little more tricky. We've been doing multiplication already with parentheses, but not like this up here. So I'm real curious to see what y'all do with this. So I'm going to make up my own problem first. All right. So how about if I say multiply and simplify the following. 2x minus 3 times x plus 4. This by itself is what we call a polynomial. It only has two terms, but it is a polynomial. What does the poly mean? Poly means many, right? Okay, good. More than one. Poly is many, and nomial, polynomial. Nomial is a single term. A single term is a nomial. That's what we call them. If you have two terms, we call it a binomial. If you have three terms, we call it a trinomial. But in general, they're all called polynomials. So this is a polynomial, and this is a polynomial. If we multiply these two polynomials together, how would you do that? I know someone in here has heard it before, and it's cute and everything.
You do like the square, where you can put in the values in the square.
Okay, so you have it like a picture that you could do it. Yeah, I've seen that also. Yes? Like you draw an actual table. Uh-huh. I was looking for a cute word. I thought for sure y'all would have heard it. Foil. Okay, there you go. It's your second favorite F word. Yes, that's it? How many, show of hands, how many of you seen FOIL? What does it stand for?